For question 7 we have a revisiting of trig, which is one of the more complicated topics in second year. Sometimes it takes trig a while to get your head around, so we're going to keep visiting it again and again and again until it makes sense. So in here we're asked a fairly standard question, which is to express a f of x given in this form in a different but equivalent form. So our first thing we're going to do is we're going to start off by writing out the function that they're given us. We're then going to use the formula book using the a plus b expansion to expand this. So this is the cos a plus b, so we get cos a cos b minus sin a sin b, and multiplying this by r. So once we've got this, we can move forward to finishing off this question. We need these two things to be exactly the same, so those two have to be equal, and these two here have to be equal. And this only happens if 12 equals r cos alpha, because then we're going to get cos x in both of them. 12 here equals those two bits, and 4 equals r sin alpha. You can either have the minus outside this and have it as 4, or you can have it as minus 4 and minus r, and then the minuses will cancel. Once we get these, there's a very simple way of solving these simultaneous equations. If we do this one divided by this one, the r's will cancel and we'll get tan alpha equals 4 over 12, which is 1/3. If we just pull the sheet back very quickly, it tells us that alpha is measured in degrees between 0 and 90. So we've got our calculator set in degrees. We can tan minus 1 1/3 and get our value of alpha, which is 18.4. You see, I'm going to use 435 here as my exact version for later calculations, but for my final answer I'm going to give alpha equals 18.4. So this is the one I'm going to use for calculations. This is the one I'm going to state as my answer, because I want my answers later on to be as accurate as possible. We can also find r by doing r squared equals 12 squared plus 4 squared. 12 squared plus 4 squared. So we get 12 squared plus 4 squared, 160. So r equals square root 160. We're just going to have a very quick look if we're asked to give r in any particular form. They've not said it as a surd, so we can do square root answer equals, and we can give it as 4 root 10. 4 root 10, or we could give it as 112.65 if you wanted. I'm going to use 4 root 10 because it's accurate for the entire rest of the question. So for part A, all we were asked to do is find the value of r and the value of alpha. This is a set method. We write out the expansion, we compare parts, we solve this using tan alpha and r squared from Pythagoras. So sorry about these little errors in here, that's a 4. And that's 12 squared plus 4 squared. For part B, we should notice the first word of part B is this word hence. This word hence means using the thing you've just done. It doesn't say hence or otherwise, it says hence, so we have to use the previous bit. If you try and solve this without using the previous bit, they can give you no marks because you've not followed the instruction. So hence means using the thing you've just done. So we'll notice that this thing here is the same as the thing here, and it equals 7. So we can write down 12 cos x minus 4 sin x equals 7 is exactly the same thing, or implies 4 root 10 cos x plus 18.435 equals 7. All we've done is replace this with the result we had from part A with our alpha and our 4 root 10. We can now get cos x plus 18.435 equals 7 over 4 root 10. What I'm going to do is I'm going to use a new value of real theta, which is equal to x plus 18.435. If you'd rather solve this without putting in a substitution or a replacement, you're welcome to, but this I think is the easiest way to do it. We're told to use 0 and 360 as our limits for x, So theta is going to be between 18.435 less than equal theta less than equal 360 plus 18.435, which gives us 378.435. So we're going to now solve cos theta is 7 over 4 root 10. We're going to solve this problem in this range, and then we're going to try and work out the values of x once we've got our values for theta. So our first answer we're going to get using cos minus 1. We check we're in degrees, so we get cos minus 1. We've got a fraction, we've got 7 over 4 root 10. We're cos minus 1ing it, and our first answer we get is 56.3995. Once we've got this, if you remember the standard cos graph, we can get our other one by doing 360 minus. So I do 360 minus answer, I get 303.600. Once I've got these two answers, remember these answers are for theta, I can work backwards, just checking both of these answers here are in there, so we don't need to make any other changes. So we can get x is theta minus 18.435. So we just need to subtract 18.435 from both of these answers. So while I've got this one on my calculator, I'm going to do this one, minus 18.435. So our second answer is, so we get x equals, let's just move this up so you can see it, x equals, our second answer is going to be 285.165. We'll round them later. And the first answer is going to be our 56.3995, take away our 18.435, which gives us 37.9645. Rounding these properly, because we're supposed to be giving these to 3 significant figures, it doesn't say anything different in the question. Oh no, giving your answers to 1 decimal place. So we've got 37 point, this is going to round up, so it's going to be 38.0, and this one is going to be 285.2 as our 2 answers. So those are our 2 answers for part B. So we've got those 2. Moving on to part C and part D, or part C, both parts of part C, we're asked to write down, so without any maths at all, just thinking the minimum value of this. Now if you think about this, this is going to be a cos graph, which would normally look like this, and this cos graph is going to be transformed by our 4 root 10 cos x minus 18.435. So this is going to be translated and stretched. So actually this stretch here, it usually goes up to 1, it's going to tell us what the maximum minimum values are going to be. So it used to go between 1 and minus 1, but it's been stretched up to 4 root 10, so the minimum value is actually minus 4 root 10. So this is for CI. For CII, we know that cos of 180 equals minus 1. That's the normal minimum point of a cos graph. So we just need x minus 18.435 to equal 180. Because if we put this number here into our cos, we'll get 180, we'll get minus 1, we'll get to our minimum point. So x just equals that plus that, so we get 298.435. Let's just have a look and see if we're given any kind of find 2 decimal places. So it's a good job we kept it accurate. So we're going to write this as x equals 298.44. See, going to extra accuracy is quite often useful later on, because you can't go back and unround something. So that should be our final answer. A very quick correction to this question, because I've noticed that there's actually a minus sign in here. This here is going to be a plus, which only changes the fact that this should be a plus. And when we redo our calculation, we're going to be subtracting. So we've got x is 180 minus 18.435. So we get 180 minus 18.435, which gives us this number here. So we get x equals 161.57 once it's been rounded. So sorry about that.